Good morning, everybody. This is your 2.7 homework on page 157. We're going to start out with problem numbers 9 and 13, which are both having to do with the transformation of functions. And it says sketch the graph and then describe how the transformed function is related to the original function. So let me find, I'm just going to sketch a coordinate plane. And then it says I can use a graphing utility. So I'm going to use my Desmos. And okay, thought I had lost my keyboard. So 2 over x. And there we have our double boomerang. And then it's always good to be able to see what you're expecting to happen. So I see that this plus 1 is in the k position. So on my next graph, when I do 2 over x plus 1, and I want to make sure that that plus 1 comes over and is not up underneath. And so you can see that the 2 over x plus 1, that's the one in blue, and it is just transformed up 1 unit. And also I want you to notice your 2 over x graph. You've got a couple of critical points at 2, 1, and 1, 2. So remember that the parent function was at 1, 1. So 2, 1, and 1, 2 is the original. And the original has asymptotes on both of the axes. And then let me get a different color. So the plus 1, I can draw my asymptote here. Now, it didn't shift left or right, so it still has an asymptote at the y-axis. So my critical point there, they'll just be slightly altered. There we go. Okay, and then in number 13, we're going to have a similar type of situation. Here the original function is 2 over x squared. And then the transformed function will be 2 over x squared minus 2. So again, I'm going to predict that that's going to go down 2, since that is in the k position. And then let's take a look at what 2 over x squared looks like. And I'm actually going to see if, can I add a square? Can I add it onto that x in there? Okay, no, I'm just going to retype it. 2 over x squared. Oh, look at that. And then 2 over x squared. And then I arrow over and go minus 2. And so there you go. So my original function has the asymptotes still at the x and y axis, but with a little bit more symmetry around the y-axis. And then my transformed function, it's just down 2. So even though the calculator doesn't show the asymptotes, I like to show the asymptotes. There we go. Alright, number 17, I'm going to sketch the graph of the rational function by hand. So this is one of those where you're attempting it without the calculator first, so we're going to follow all those steps that were given. And so 1 over x plus 2 is our function. And I'm going to draw a set of coordinate planes. And then I'm going to refer to my steps. So I'm going to flip back a couple of pages. Those steps, if either they're in your notes or on page 151, there's a great chart. So step 1 is to simplify f, which it's already simplified, and any restrictions in the domain not in the simplified. Okay, so that's if you had canceled something out, you would want to specify any holes or anything like that. So next we'll find and plot the y-intercept. So that's what do we get when we plug in 0 for x. So 1 over 0 plus 2 is 1/2. So I'm going to go ahead and plot that point. That's on my graph. I want to find the zeros of the numerator, if any. So there's no x's in the numerator, so there are no zeros in the numerator. The 0 of the denominator, so that is going to be my vertical asymptote, which is going to be when x is -2. So I'm going to go ahead and plot that. Then if there are any other asymptotes, so it looks like my horizontal asymptote, remember my technique where I visualize what is the, oh gosh, sorry, couldn't even see this the whole time I was writing. So I visualized the, I want to have the same degree of the polynomial. So if I have a 0 up here and a 1 down here, my horizontal asymptote will be at y equals 0, because 0 over 1 is defined. So I've got a horizontal asymptote here. I've got one point here. So it says plot at least one point between and one point beyond each x-intercept and vertical asymptote. So between and beyond, so I would say I should plot, I should say what if x is -1, and then what if x is like 1 or 2 or whatever. So at -1 I substitute that in. 1 over -1 plus 2 is 1 over 1. So now I can tell, and then if I put in x equals 1, my fraction just keeps getting smaller and smaller. So I can tell already that my curve is going to look like this. I think because it's an odd power, I think I'm going to end up down here in this third quadrant on the other side of my asymptote, but that's where I need to plot a couple of points. So I would plug in just like 3 and 4. Sorry, -3 and -4, just to see the shape of that graph. So 1 over -3 plus 2, that's 1 over -1. And then 1 over -4 plus 2, that is -4 plus 2 is -2. So that's -1/2. So you can kind of see the symmetry there. So that's how I would develop that graph. In number 21, let me adjust my camera. Still not perfect. Let's see. There we go. Okay, so let me get number 21, which is going to be a similar step process. F of t equals 1 minus 2t over t. And so we're going to start out, I'm going to go back over to my list of steps, and I'm going to sketch my coordinate plane. And the first step was to plot the y-intercept. So that's when x is 0, or t, I guess. T and f of t. So when I plug in 0, I get an undefined, and 0 actually turns out to be my vertical asymptote. So There we go. Vertical asymptote. And then I can't really simplify because this is not factorable. So my vertical asymptote, x equals 0. My horizontal asymptote, that's going to be, if I look at the coefficients, that's going to be a 1. Negative 2 over 1. So I'm expecting a horizontal asymptote down there at negative 2. And then I want to solve for that critical value up top. Where is the numerator equal to 0? So that's where I want to plug in and say 1 minus 2t equals 0. Subtract 1, divide by negative 2. So that's t equals 1/2. So at 1/2, my function, so here's a 1, at 1/2 my function is 0. So those are my critical points. So now I pretty much want to graph a few points on this side of my asymptote and then a few points on this side so I can see where the graph is. So I'm going to do 1 and 2, and then I'll do negative 1 and negative 2. So when I plug in a 1, 1 minus 2 times 1 is negative 1 over 1. So at 1 I get negative 1, and at 2, 1 minus 4 is negative 3 over 2, negative 3/2. So it's going in a downward direction. But remember, it's got that asymptote there. Then for let's see, negative 3/2. For negative 1, I can show my math. 1 minus 2 times negative 1 over negative 1. So for that I'm going to get 1 plus 2 is 3 over negative 1 is negative 3. Negative 1, negative 3. And then negative 2, 1 minus 2 times negative 2 over negative 2. So 1 minus, or 1 plus 4, that's 5 over negative 2. And of course you can use your calculator. So at negative 2, we're down at negative 5/2. So that's slightly less than negative 3. And so I'm going to sketch in my curves that way. So I'm going to have to double check the tests. I'm assuming, since we're having you practice doing this on the homework, that there's going to be some component of this on the test. Of course, I've already warned you, you're going to have to find intercepts, asymptotes, those sorts of things without the calculator. So even if you don't have to do a full graph, it's still good practice. Number 23 is next. So let's see. Then if I were you and I were just starting out at this, I would plug that into my calculator after the fact so that I could check it. So number 23, this is our first x squared function. We've got an x squared on the top and x squared minus 4 on the bottom. So first thing we want to remember is that we have to simplify our expression first, which means if it can be factored, you must factor it. So there's the factored form of the equation, and that's going to tell me some information about my asymptotes. So it looks like I'm going to have a vertical asymptote at x equals negative 2 and x equals 2. So let me go ahead and sketch those in. And then let's go ahead and talk about horizontal asymptotes. I've got 1 over 1, so it looks like I'm going to have a horizontal asymptote at y equals 1. So this is one of those graphs that appears to be divided into 6 sections. So I'm going to have to do, well, I'm going to plug in 0 for everything and see, but I'm going to have to do some points in here, this section, and this section. So let's do the y-intercept first. So it's x and f of x this time. So at x equals 0, I plug in 0 on top, 0 over -4, which is 0. So the origin is a point. And so I can see what that graph looks like by plugging in 1 and -1, and that'll give me a clue on that one. So if I plug in 1, that's 1 squared over 1 squared minus 4 is -3. So, and then if I plug in -1, I get exactly the same thing. So that is telling me I'm dealing with a downward opening parabola. Alright, and so now I want to come over here to these sections. I'm going to do a 3 and a 4 and a -3 and a -4. So when I plug in 3, I've got 3 squared over 3 squared minus 4. So that's 9 over 5. And you know what? I can say that's what I'm going to get over here as well. -3 squared over -3 squared minus 4. The squared makes this negative go away. So that's nice. It's at least saving me some work. 9/5, that's 1 4/5. So if there's 2, I'm just going to go a little bit below it and plot a point. Now let's see what happens with 4. 4 squared over 4 squared minus 4, that is 16 over 12, which is 4/3. And that is less. Alright, so it's going in a downward direction, and that one is less. So there is the sketch of my graph. Alright, question number 45. I started to have a little bit of a panic because I thought we have not done any absolute value equations, but then I read the directions and it just says use a graphing utility to graph. So all we want to do is plug in that function, and it's 4, and the absolute value, got to find that function. It's over here, 4 times the absolute value of x minus 2 and then over x plus 1. Alright, look at this jacked up function. So what do we observe about the asymptotes? So I see that I've got, let's see, does this thing, oh look at that, it crosses over the the y-axis, and then it has an asymptote, a vertical asymptote at x equals -1, which we expected, right? And then down here, same thing, it's honoring that vertical asymptote at -1. And then let's take a look at our horizontal asymptote. So I've kind of got, you know, if I were to use the distributive property here, I've got a 4x over x. So it looks like I've got a horizontal asymptote. Let's see, let me get back up. Well, I was expecting a horizontal asymptote at 4, but it looks like it's at -4. So maybe because it's absolute value, we end up with the opposite. So that's all. It says, what do you observe about its asymptotes? I observed them. I think I can see how it's somehow related to the coefficients, but it looks like it's opposite. So that is the extent of my observations there. And now let's look at number 47. And if I follow my rules, well, let's see, I'll go ahead and graph it, but I do want to anticipate some things, okay? So always in every single one of these, I've attempted to simplify my function in order to find my asymptotes and my domains and everything that's true about the graph. So this one's no different. I see that I have a quadratic trinomial in the denominator that I want to simplify if I possibly can, but as I'm trying to factor this thing, I see there's no multiples of 5 that will add up to -4. So this is not factorable. So therefore I'm kind of just looking at 4 over 1 to see where my horizontal asymptote is. So I'm going to go ahead and plug that in. 4 times the quantity x minus 1 squared divided by, and then I'm going to put that denominator in parentheses, x squared minus 4x plus 5. And typo there. There we go. Okay, now there's my graph. So, do we have any asymptotes? Looks like, you know, there's no vertical asymptotes. And if I recall, we had an example like this where we had imaginary stuff in the bottom. So if there's no real values that are excluded, then we end up with no vertical asymptotes. On my horizontal asymptotes, my prediction was that it would end up around 4. And so as I look, I see how I've got that horizontal asymptote. Both ends of my graph are approaching that line at 4, and it won't actually touch it. So that is going to be y equals 4. And those are my observations about the asymptotes. Now let's look at 49. And 49 is going to be our first slant asymptote, which we talked about on Friday. And I only know that because that's the title in the directions. So I look at my function, 2x squared plus 1 over x, and I see that the degree is 1 more on top than it is on the bottom. So sketch the rational function by hand. So I'm going to use my same techniques that I used at the beginning here. So I'm going to start out by plugging in x equals 0 to get my y-intercept. And when I plug in 0, that's dividing by 0. So that's going to be one of my asymptotes. And then instead of having a horizontal asymptote, I'm going to have a slant asymptote at y equals, and so I've got to do long division to find out the equation of that. So I'm going to take 2x squared plus 1, I'm going to say plus 0x plus 1 divided by x, so that's 2x times x, 2x squared, that's 0, plus 0x, that's 0, plus 1, and that's my remainder. So my slant asymptote is going to be the equation y equals 2x. So y equals 2x crosses at 0, and then you go up 2 over 1. So that just tells you about the slant or the slope of that line. And so we need to pick values on either side of that to plug in to kind of see what our equation is going to look like. So I'm going to pick 1 and 2, and then I'm going to pick -1 and -2. So if I pick 1, 2 times 1 squared, 2 times 1 plus 1 is 3 over 1. So 1 and 3, 2 times 4 is 8 plus 1 is 9 over 2, so that's 4.5. So at 2, got 4.5, so some kind of a, something like that. And then at -1, I've got 2 times 1 is 1, this one is 3 over -1, that's -3. So at -1 I'm down at -3. -2 I bet I'm going to be at -4.5. So that's right. So that way, there's my graph. Okay, last one, number 65. And oh, sorry, I crossed over my asymptote there. That is my bad. So I should have, like, it's more like a V, and I can't touch that asymptote. So there's that, and then it kind of, sorry about that. And you should check that on your graphing utility to make sure that you get it sketched correctly. Okay, last one, number 65. Let's see what we're getting into. Finding asymptotes and holes, find vertical, horizontal, slant, and holes. So let's look at 65. What kind of a function is that? Looks like, I hope it's a factorable function. X squared minus 5x plus 4 over x squared minus 4. So this function definitely factors. So let's go ahead and break that down. We have x, we're going to have -1 and -4. And then on the bottom, that's a difference of squares, so x plus 2x minus 2. So actually nothing cancels, so we have no holes. We have a vertical asymptotes, we have 2 of them, at x equals 2 and x equals -2. We have horizontal asymptote, we have the same powers here, and so here I'm coming back to the unsimplified function. 1 over 1 is 1, and then does it say we actually have to graph? And there are no slant asymptotes because my degree is not 1 more. And then we'll use our graphing utility. So get x out of there. So x squared minus 5x plus 4 divided by, we don't want to just divide the 4. So let me put a parenthesis there and a parenthesis there, and now I'm going to divide the whole function by x squared minus 4. And so, let's see, oh look there. So I've got a double boomerang and then I've got a cubic function in the middle of it. Could not have predicted that, but you can kind of see how that horizontal asymptote is there. There's the vertical, the 2 different verticals. So it's really, you know, anytime you have those 2 verticals, the vertical asymptotes, and then a horizontal, and your graph is divided into 6 regions, that's when you can end up with something in several of the regions, because the behavior is different at each interval along the graph. So did you have to sketch it? You didn't really have to sketch it, but it just helps you verify that your asymptotes are making sense to you. Okay, that's it for this homework. Sorry so long.